Alright, today we're going to learn two things for Chapter 3, and it's unknown numbers in addition, unknown numbers in subtraction. As you see, I have a new shirt. That means I ran out of time yesterday, couldn't finish the video, so it's a new day. Anyway, we're going to look at the problem. 4 plus 3 clearly is 7. The two numbers that are added together are called add-ins, add-in, add-in, and the answer is the sum. What happens when we take one of the add-ins away? We have 4, we add some unknown number to it, and we end up with 7. I'm sure most of you probably know the answer is 3 because we just went over that, and plus you can kind of just, most people, the answer comes to them because they have good number sense. But I want you to pay attention to the process of this problem. How do we figure it out? Well, we're going to do something, math is very logical. It's called deductive reasoning. You start with your conclusion of the problem, which is 7. And then you go backwards. You're thinking 7. Well, if I had 4 at the beginning, what did I add? So I'm going to subtract 4 from 7. 7 minus 4 is 3, which is what we are looking for. Let's look at it in a different way. Okay, this is a fun way to look at this, the logic of a problem like this. This is my kid's train set. As you see, this train has 1, 2, 3, 4 cars on it. We're going to go up, and if I can get it to go up the hill here, and we're going to go into the cave. Okay? As the train comes out of the cave, a little mountain pass here, we have 1, 2, 3, 4, 5, 6, 7 cars on the train now. 1, 2, 3, 4, 5, 6, 7. What has happened in the cave? Alright, so this is the mathematical representation of what just happened with this little train set here. We started with 4 cars. The train went into the cave. A certain number of cars were added because when we came out, we had 7 cars. What was added inside the cave? You do this little problem, 7 minus 4, and you find out that there were 3 cars magically added in the cave. So this is, if it confuses you, don't worry about the train analogy. But if it helps you, that's the kind of mathematical reasoning that algebra is. There's a lot of deductive reasoning in that. Okay, so let's use that same logic. This is actually example number 1. Let's use that same logic and solve a problem that's a little bit more difficult. Okay, so we start out with 12 cars on our train, so to speak, and then we add something mysterious. The train goes into the mountain, and when it comes out of the mountain cave, the train now has 31 cars. So what has happened in between when we had 12 and when the train came out and having 31? So we're going to go 12 plus m equals 31. Well, let's go backwards. Let's do 31 minus 12 equals what m is going to equal. So doing that, how you would do this on your homework is you would just write to the side of your homework problem neatly. 31 minus 12, borrow, 11 minus 2 is 9, 3 minus 1 is 1. So, m equals 19. How many cars did we add? 19. Okay, sometimes these problems even get a little bit more difficult. Here we have 36 plus 17 plus 5 plus an unknown number equals 64. So the first thing you have to do is you have to do something called combining like terms. In this case, that just means you combine 36 plus 17 plus 5. So we're going to do that over here, write it up and down. Make sure it's very neat. Everything in the 1 spot is all lined up. There shouldn't be a number that's in the 1 spot that's over here under the tens column. Okay, so 6 plus 7 is going to be 13. 13 plus 5 is 18. 8 goes down there, carry the 1. 3 plus 1 is 4, plus 1 is 5. So we have 58. So 36 plus 17 plus 5 is 58. Bring down the n, because we haven't evaluated that yet, equals 64. Now remember back to problem 1. We're going to use deductive reasoning. How do we do that? When we go backwards, instead of adding, we're going to subtract. So 64 minus what equals n? So do that over here. 64 minus what number? Well, that's going to be 58. Okay, borrow from there. 14. That's going to be 6. So we know that n is going to equal 6. So what happened in between 58 plus n and 64? Well, we know that we added 6 to 58 in order to get 64. How do you check that? Just take 58. Let's do it over here on the side. 58 plus 6 is going to be 64. That's how you check to know that it's right. If this is 64, whoop, and this is 64, that means it checks out, you got the right answer. Okay, quick review. In a subtraction problem, the answer is, of course, the difference. The first number is going to be called the minuend. The second number is the subtrahend. So remember, this is the first number, second number in a subtraction problem. Okay, you can find that when there's a missing number in a subtraction problem, and it's the first number or the minuend, you can find this number by adding the other two numbers. And you can only do this when the first number is missing. If the second number in a subtraction problem is missing, you can't do this little algorithm. We'll show you how to do that in a second. So if the first number is missing, you just add these two. 5 plus 3, which is going to be 8. And that will be your answer for F. Okay? Here's a problem that's a little bit more difficult. We have W minus 16 equals 24. So since this is the first number in a subtraction, or since the first number is missing, then we can add these two numbers in order to find that number. So over here on the side, 24 plus 16 is going to be 40. So we know that W equals 40. If you want to check that, you can simply take your answer, 40 minus 16. 40 minus 16, if you do that real quick, borrow 3 minus 1 is 2. You'll get 24, which is what you started with. So it checks out that your answer is correct. So that's how you check your problem. Okay, in the problem we just did, we had the first number in a subtraction problem was missing. W minus 16 equals 24. So we had a missing number as a first number. In example number 4, which is our last example for this chapter, is we have the second number is missing. So it's 236 minus, we'll say S for second number, and that's going to equal 152. Okay, so 236 minus S equals 152. So in example number 3, we took the second number and we added it to the difference to find the missing number. But when the second number is missing, there's a little bit of a different algorithm we have to do. So first step is you're going to take the minuend, or the first number, 236, and you're going to subtract 152 from that. 152 is your difference. So you're going to take the first number and subtract the difference, or your answer. Okay? So 6 minus 2 is 4. Borrow. 13 minus 5 is going to be 8. So your answer is 84. So S should be equal to 84. So if you want to check to see if this is a true statement, I'm just going to take, since S equals 84, I can take 84 and put that in wherever there's an S. So look for an S. Let's just erase that. Here's an S right here. Let's put 84 right in for S. The reason why I can do that is because 84 in this problem equals S. S and 84 are the same, so they're interchangeable. So what we're going to do is we're going to take 236 and subtract 84 to see if that equals 152. So let me write that out really quick. 236 minus 84. 6 minus 4 is 2. Borrow, 13. So that's going to be 50. Bring the 1 down. 152. So 236 minus 84 is 152. Does 152 equal 152? The answer is yes. So that's the end of chapter 3. You know how to find a missing number in subtraction, and you know how to find a missing number in addition.